Only a small proportion of the very best students were able to score full marks in this question. Would you have been one of them? Let's find out. Figure 2 shows a sketch of the curve with this equation, given on this domain with this range. Find dx in terms of y. So notice that we're differentiating x with respect to y. And we've got x equals here, so we can just differentiate this as normal. So how do we do that? Well, we differentiate the 2y to get 2, that comes to the front. We already have the 3 here, so we need to multiply that by 3. And then we need to differentiate cosine. That gives us minus sine, but be careful, not minus sine of y. It's got to match. Here, it's got to be 2y. So overall, what's that giving us? It's giving us minus 6 sine 2y. If you get that, you get both of the marks. Part B says, hence, show that dy by dx is given by this equation, where k is a constant to be found, for 3 marks. So in part A, we found dx by dy. In this question, we're asked for dy by dx, but notice that we're asked for dy by dx in terms of x. Here, we've got dx by dy in terms of y. So we're going to need to convert this y here into some function of x. How can we do that? Well, we can use the equation that we were given in the question, x equals 3 cos 2y. And therefore, cos 2y, if we divide by 3, would be x divided by 3. Notice, though, that dx by dy involves sine 2y, not cos 2y. What's a formula that you know that links cos 2y to sine 2y, though? Well, you should know that sine squared plus cos squared equals 1. And therefore, if I'm wanting to replace this sine 2y, I'm going to isolate sine 2y by subtracting cos squared, first of all, then taking a square root. Normally, I'd have to worry about plus or minus signs here, but in this case, we know that y is positive, so sine 2y will be positive on this given interval. And here, we've got cos squared of 2y. So that's cos of 2y, that's x over 3, but don't forget we need to square that there. This is x squared over 9. If we make a common denominator with the 1 here, we'll end up with 9 minus x squared over 9 in the square root. Then we can square root the numerator, and square root the denominator, or the square root of 9, is 3. Just to tidy that up a little. So now we know that sine 2y, which was part of dx by dy, can be rewritten in another way. That sine 2y, that's here, can be replaced with what we have here. So that can go in this slot to appear here. And you see that then we have minus 6 divided by 3, that's minus 2. But be careful, that's dx by dy. We were asked for dy by dx. So we just need to think of this as a fraction and flip it over. A fraction over 1, flip that over, i.e. take the reciprocal, and we'll end up with the final answer here for 2 marks. So hopefully you can see that the k value that we have is minus a half. Next it says the point P, the point AB, you can see that on the diagram, lies on the curve and is shown in the figure. Given that the gradient of the curve at P is negative a quarter, and both A and B are positive, find the exact values, so no decimals allowed, of A and B for 4 marks. So in part B, we worked out that dy by dx was given by this equation here. What about at P? Well, we know that at P, the gradient of the curve, and therefore dy by dx, is negative a quarter. So at P, dy by dx, the gradient of the tangent to the curve, is negative a quarter. So we end up with dy by dx here equaling minus a quarter. Notice that we can multiply both sides by minus 2 to cancel out this part. That will cancel out the minus sign, cancel out the 2 here, and it will mean that this side becomes a half. So we have this equals a half. Again, if we take the reciprocal of both sides, then we'll eliminate the fractions, and we'll end up with, well, this part equals 2. Next, to get rid of the square root, we square both sides. That will give us a 4 here. And then if we rearrange this equation, we end up with x squared equals 5. Taking a square root leads to x is plus or minus root 5, but because it said that a is positive, it must be that x is positive root 5. That's the a value. Remember, the point A is the x value of P. How can we find the corresponding y value of P, the b value? Well, we know that P lies on the curve, and we have the equation of the curve here, and we've just worked out the x coordinate of that curve, so we can sub that in here. Divide by 3 gives us cos 2y equals this, and then we need to eliminate the cos by taking arc cos of both sides. That will leave us with 2y. Finally, we get rid of the 2 by dividing by 2. We end up with a half of arc cos of root 5 over 3 as our y value, and remember the y value was the b value here for our final 2 marks. Do you think that you would have scored full marks in that question? What grade are you aiming for this summer, or the summer that comes? Let me know in the comments.